All right, so to answer your question, if you go to my YouTube channel, right, and you go to playlists, there, I'm trying my best to put all the courses into. I stopped labeling it with the course numbers because honestly, that was a couple of keystrokes extra that I realized I didn't need. What I'm doing is I'm throwing each of the videos into a playlist. Right, so it's a summer 2018 1051 and summer 2018 1068, and the number of videos just depends on how many cuts that I do. Occasionally, I'll trim the videos in the editor, but that's about it. Let's see. So I'm going to go ahead and we will take. Let's see. Let me go ahead and switch this to just viewing me for a second so that I can look at roll. Alright, so, alright, let's look at the roll and see who is here. Alright, so Hiromitsu Arai, Lane, right? Ian Hoole, Yuya Kanai, David, you're here. Jesse Leung, Alexander Niang, Matthew Perez. I'm here. Yuki Sei, right? And Jalen Shaw. Okay, so everybody who was here last time, right? No? Your first time. Okay. Okay. So, while we're working on, so were you able to watch the YouTube videos at all?
I couldn't find them. I just saw there were one on campus.
Okay, so we're missing some people who were here last time, and I'm not sure. I really should take roll better, which is why I'm going to start doing quizzes in class. So, congratulations, you're going to be subjected to your first quiz here, and you probably don't know much programming at all. You'll survive. I think you'll be able to surprise yourself. Okay, so in that case, let's just review a bit of what we learned earlier. Okay, so we've got, so your first step, of course, is that you will want to go, if you've got a laptop, you want to go to python.org and download yourself 3.6.5. Okay, and what we'll be programming in for right now, you don't have to use this, but it's the tool that comes with Python, and therefore it enables me to ignore a lot of other complicated steps, right, is idle, which you can use as basically a very powerful calculator to do stuff, and that's really what we've learned to do right now, right? And you can also write scripts as well. So there's two modes. There's the shell mode, and then you've got the script mode, and we can do things like set up variables, x is equal to 5, right? And then if I ask what 5 is, for instance, if I ask it to print 5, it prints 5. And I can store floats in there. So we've got our integers, we've got our floating point numbers, and then we've got, oh, that's right. I'll have to change the answers on the quiz. So I will have to terminate this and give me 1 second when I do give you guys the quiz. So that's okay. So let's talk a bit more about variables. So today's schedule, we're going to talk about the fact that variables are about this equal sign that we've seen before, right? So I've been saying it's equals, but it's not really equals is kind of the idea. But we call it equals because it looks like an equal sign, but it's really the assignment operator. So that's what we're going to talk about today. We're also going to talk about another type in Java, so in Python, which is called Boolean values. So Boolean values are either true or they're false. And in Python they're capital T and capital F. And I'm going to mess them up all the time because in Java it's lowercase t and lowercase f for true and false. Okay. So they're very simple types, but in Python it gets kind of not so much complicated as that. As a bit complicated. Well, it gets a bit more involved because values have what we call truthiness. For instance, which is that to say that anything that's not a 0 value is true, and anything that is a 0 value is false when we have to evaluate things to see whether they're true or false. If that makes any sense. That doesn't have to make sense right now. So let's go ahead and talk about the assignment operator. Okay? So we can assign various values to x. We can assign x is equal to 5.0. We can say that x is equal to 6. Oh, I had a space there, so that didn't work. X is equal to 6. Boom. X is equal to 6. We can also do x is equal to, we can also set up like a second variable. X is equal to, so let's say y is equal to 100. Very distinct value there, right? So I can print x. I can print y. I can also, you know, what's cool is that with the print, right, it's what we call a function. So it can take multiple parameters. I can give it, right, I was giving it one parameter. I was telling it to print x. I was telling it to print y. But just like functions sometimes can take 2 parameters, I can give print 2 parameters. That's what the dots mean over here. It means I can do as many as I want. So x, y, I can print them both, and it'll print them both and separate them by spaces automatically for me. So that's pretty nice. So again, these are all expressions that I'm doing that Python's just evaluating. Okay? So print. And there's orders, right? There's an order of operations, right? For the most part, it revolves around the same order of operations that you learned in 4th or 5th grade if you were in the American system, which is that you do parentheses first, right? Right? You do parentheses first, then you do multiplication and division from left to right. And then, and only then, will you finally do addition, right? So this would do 5 plus 2 first, okay, because it's in parentheses. And then that will become 7. So 7 times 4 is 28, okay? And then 28 divided by 2 is 14, and then minus 1, which is 13. Now it gave me 13.0 because whenever we see a division sign in Python, it goes from being integer values to floating point values, right? It starts going from whole numbers to numbers that don't necessarily need to be whole numbers. Okay. So that's pretty nice. So that's that's a feature of Python that's not necessarily in other languages. So it works off the same rules that you've been working with since forever. So we're just going to start adding operators on top of that. And this assignment operator works actually kind of intuitively the way you would think it works. First off, we need a variable on the left side of the assignment operator. Okay? You can't do 5 equals 6, right? You can't assign to a literal. What is a literal? Well, it is literally something, like literally a number or literally a word. Okay? Because it's not the equal sign that, again, it's not the equal sign that we're really doing over here. So x is equal to 6 plus 2, or sorry, plus 3, I guess I put. So we're doing 6 plus 3. Okay? And the order of operations say we do the addition, and then at the very end, that's when we do the assignment. So the assignment operation always comes last after everything else. That makes sense to everybody? So consider it another operator, and it always comes last. So x now has the value of 9. Okay? And a thing to remember about this is that I keep calling it the assignment operator, and so why are we using the equal sign? Well, let me go ahead and try and shoot the camera up here, right? So really what it's looking like is I'm doing x is, this would be a better symbol for it, an arrow sign, 6 plus 3, right? X is equal to 6 plus 3. However, we have some issues. One, I don't have an arrow key on my keyboard, right? Because we didn't plan ahead. So there's no arrow key, right, to do that prints an actual physical arrow. There's one that goes to the left, but that's not going to help us here. Okay, we need that to move to it. Okay, so, okay, well, maybe we can use 2 keys. So I can draw an arrow like this, less than sign, minus sign. Well, now I'm going to parse this as x is less than -3 plus -6 plus 3, right? And I need to be able to do comparisons to negative numbers. So I don't want this to, so I can't really use this for an arrow. What about this? Well, I've just made it worse, or, well, not worse, or nor any better. I've done x is now less than or equal to 6 plus 3, right? So I can't really draw an arrow. And I mean, of course, if I do 2 of these, well, even if I can get that to work, right? Now I have to do an assignment operation, which is super common. I have to do 3 keystrokes, right? Sorry, well, I have to do less than minus minus, so that's a shift and a keystroke, and a keystroke and a keystroke. And we're lazy, so we don't want to do that, okay? So some programming languages, what they did was they did this little weird sign, which is that they did colon equals, and if you squint at it in the dark, it kind of looks like an arrow, okay? You squint. Now, this is actually still used in some modern programming languages like Go, which is the Google programming language. And what it's really cool is that in those languages, you have to define it. In languages like Java and C and Go, you typically have to define a type. And Go does it in reverse, where they would go something like x is an int, right? And it's equal to 5, right? Right, and you define the type. And in Go, you get to do this kind of type where you kind of can do what you do in Python, where you just say, just figure out that it's an integer and store it in x, okay? And that's nice. So that still does have some special uses, but most languages, they've just said, well, you know what? The single equal sign, we use it so often, we'll just go ahead. This thing gets used so often, we'll just use a single equal sign. And we'll just have to basically remember what it is for the people coming into programming, which is that you take the value or the memory location that's stored on the right, and we're going to store it in the variable on the left. So you take what's on the right, you store it in the left. Okay? And if you remember that, and that's more important. Ooh, that really lit up the screen there, kind of. So if you remember that rule, it will, it will help you get through data structures if you ever decide to go that far. But because that's where a big stumbling block in data structures. But again, this is a programming class for just starting out, and also with the focus on people who are not going to be computer scientists. It's actually getting stuff done as opposed to theoretical stuff. So now, as a result, we evaluate this expression before we do this. So we evaluate this, then we take it and assign it into here. So x's value is currently equal to 9. So this allows us to do something weird that does not necessarily make sense until you remember that the x is that this is an assignment operation. Okay? X is equal to x plus 1. Now this is a very common operation called the increment operation. And what does this mean? Well, it means that we're going to take x's value, add 1 to it, and we're going to store the result in x. So take the value in x, add 1 to it, that evaluates to 10, and we store it in x. So now if we print 10, if I print x, I was printing the answer, so if I print x, it gives us 10. And if I do this again, x is equal to x plus 1, right? It increments the value. Same thing if I wanted to do x minus 1. X is equal to x minus 1. It looks at 11. It says, oh, x is 11. It says, okay, I'm going to store some value in x. What am I going to store in x? Well, I'm going to take the current value in x, which is 11, subtract 1 from it. Now I've got 10. I'm going to store that in x. And now we've got 10. This is such a common operation that other programming languages have a shortcut for it. Yep, there's plus equals, yeah, but this adding 1 or subtracting 1 is such a common thing in other programming languages that often they'll put down x plus plus or x minus minus, which means add 1, increment x's value by 1 or subtract it by 1. But Python developers decided that it actually, because there's actually a subtle difference between plus plus x and x plus plus, that is confusing, that leads to confusion, right? That they decided, well, maybe it's not great if everything looks like elite hacker code and we just actually err on the side of reasonability. There is a shortcut, though, for this. So x is equal to x plus 1. Right? So we do that again. X is equal to 11. There's also, we can, this operation is common that we do want a shortcut. And we have it, and we have something called plus equals. So I can plus equals like by 5. And this simply says increment x's value by 5. Take the value of x, add 5 to it, and store it in x. So this just expands. So x plus equals 5. Expand it. It's actually this. So I just did something over here, and notice it just came up all in red. So this is called a comment. I put the pound sign down, or the hashtag sign now, I guess. Right? So I put this sign down, and this is called what we call a comment. And a comment is basically once the Python interpreter sees the pound sign, it looks at the pound sign and says, that's a comment. So I'm just going to ignore everything in this line after it. So I'm not going to read it. That was meant for anything after that that's meant for humans. I'm not a human. I'm not going to read it. So it just operates the same, right? Increments to 21, right? Normally, if I type a bunch of gibberish into here, it's going to give me an error. If I type X and then have a bunch of gibberish behind the comment, it doesn't care about the gibberish because it says, that gibberish was meant for humans to see. How humorous, those humans. But I'm going to go ahead and just look at the stuff before the pound sign. That's what we care about. Okay, so dealing with those kind of operations, that's that's. I won't lie. I will say that those do crop up on exams to make sure that you understand how the assignment operator works. They're sometimes deliberately trickier than they have to be because some people write bad code, and you need practice understanding their bad code. However, there is something you should do. That leads me to a point in Python, which is that developers of Python, and what makes it a very popular language, is that they had an insight, which is that code is read more than it is written. Like, I'm writing code once, and you're reading it 6 times, right? Just between all of you guys, I write it once, you're gonna read it 6 times. You're gonna read code, even for yourself. If you write code, you're gonna read it, a lot, and you want it to be easy to read, even if sometimes you have to type it out a bit more. All right, so that's kind of the idea behind the assignment operator. All right, so let's see. We have, okay. So we've got a couple of things that we can, so let's see. So I think, let's see. I want you guys to, so now that, I'm going to start by so I'm going to go ahead and move on to the Boolean stuff, and then I'm going to go ahead and give you guys some of the exercises, and then we'll deal with the quiz because we've got 3 hours. And then I'll use some of the time while we're getting set up to review with you. So to make sure that I can catch you up to speed, because Python, fortunately, is really easy to learn. Okay, so now there's essentially, all programs are made up of essentially 3 different things, and we've been working on the first one, which is essentially commands, doing things. Like for here, I can basically get a string from the user, right? X is equal to, let's go ahead and write a script instead, and save it in, let's see, Andrew. So now I'll start actually storing a code here for class. So let's go ahead, new folder, code. Oh wait, no, that shouldn't be in there. It's in the classroom. That's where my code should be uploaded. Yeah. let's go ahead and call it okay. So we've got essentially stuff that we can get. So essentially the interpreter just runs through this one command at a time. So I can say like word is equal to input to get something from the user. And it's probably a good idea to instruct them, tell the user what we want. Please enter a bunch of characters. Or let's get it. Please enter a string. I will tell you how long it is. Okay, and then we can use the input function. So we use the print function to print that out, and then we get use the input function to read from the user and store that value in Word. Okay, so if we run this using F5, it says please enter a string. I will tell you how long it is. Foobar. Right? Doesn't do anything, of course, because I didn't tell it to do anything else other than that. Right? So now, there's actually kind of a really useful command and a really useful function in Python called length, which is very obviously short for length. Which, if you throw something in it, some kind of thing in it, it will tell you how big it is. So if I run it, please enter a string. I'll tell you how long it is. Hello. Well, it doesn't do anything because all I told it to do was calculate the length of the word. Right? I didn't tell it to print it out or anything, so it doesn't print it out. It only prints it out during the in the shell. It would only print it out in the shell, right? Because in the shell, specifically, it's a read, evaluate, print thing, right? This thing reads one line, it evaluates it, it prints out the result, and so on and so forth. So in order to print it out, I need to like store the size. I take the size, I can store it in a variable, and then I'll print out the size. And so now if I run this, it tells me that, hello, comma, how are you today? That's 24 characters long.
Including white space?
Including the white space. It does include the white space in there. So, yeah.
I was going to ask, so like, because you can just do like print length of word, right?
Yep, I was about to get into that. But generally, it's easier to break it up into, in the beginning, it's easier to break it up into these things, right? So it's a good point, right? This size is just the length of the word. So there's nothing stopping me from taking this and putting length of word inside of there, right? And now remember, now you might be wondering, oh God, this looks complicated. But order of operations, parentheses still apply here. So we do what's ever inside the parentheses. So we evaluate word. What is word? Well, it's whatever I type in. So I'm going to just type in hello, right? So that will evaluate to hello over here, okay? Right, it's going to store hello over here, so when we get a word over here, it's going to evaluate to hello. So then it's going to go work from, so it's working from the innermost to the outermost. So then it goes length of hello. Oh, well, that's 5. Okay, so we evaluate to 5. Then it's going to print 5, because that's how long the word is. And of course, it does it much quicker than I'm able to do it, because it's working with the magic of electricity and stuff. Yes?
So, would you say it's preferred practice to, like, keep everything together like that instead of individually in, like, separate variables first?
Congratulations, you have just stepped into a internet flame war. Because the question is, because there's two competing arguments. One is that, and honestly, they both have a point. One is saying, well, this way, I'm doing it. In fact, if I could do it like this, right? This way is elegant, and I don't have to store nearly as many variables, so I use up less memory. And the other argument is, that's long, it's hard to read. This way is clear to read, and therefore easier to debug, right? So those are both valid arguments, I feel. And for right now, as a beginner, it's better for you to do this. Do it like this. even though it might be a bit more tedious. But it's easier for you to debug if you make a mistake, like, you know, this, where I accidentally misspell a word, right? And then I'm going to go foo, and then it's going to, so we get over to line 4, and it says size is not defined. Now I have a very short sentence. I have very short lines of code that I'm easily able to look through and say, oh, I misspelled size. That's why it's not defined, right? Does that make sense? So it's easier that way. So right now it's easier, but if you want to do it the other way, where we decide that basically, actually, this is the easiest way to do it, where we just do parentheses wrapped in parentheses, you know, wrapped in parentheses. You can do it like that. Honestly, though, again, even at this point, I find going any more than this is a bit hard for anybody to read, right? I would still, at most, maybe do like one nested front call and another nested call at most. Otherwise, you risk it being a bit hard to read and therefore hard to debug. Mind you, this is fairly simple code. Right? Yeah, you can do it in one line. Right? Yep, we could get it down to one line. And again, it always looks cool when you get things down to one line. But we do, you know, the more complicated a program gets, the harder it is to debug. And just because something looks cool doesn't necessarily mean it's great to do. So, all right. But these are basically all commands that are just kind of chained together. Now, sometimes we want to execute a command, and sometimes we don't want to execute a command. Maybe we want to write a program that tells us how that the string we enter is a big string. So let's go with user input is equal to input. And now maybe we want to tell maybe this if the string is a big string or not. So user size is equal to length of user input. Okay. And so to determine something, we use Boolean statements. And I'll give you an example right here. It's pretty easy to just kind of grok it. And if you don't know what grok means, you're going to grok the meaning of grok in just a second. So if size is, oh, wait, in Python, I don't need the parentheses. If size is greater than 10, print, that's a big string. Else, print, that's a small string. So now we've got something called an if-else statement over here. And it's fairly and the nice thing is that even if you've never seen this before, you can pretty much understand how it's going to work. If the size of the user input is bigger than 10 characters, we're going to print out a message that says that's a big string. Otherwise, we're going to print out that's a small string. And that makes good sense. So if I put in hello, it's going to check if size. What is size? Well, hello is 5. Is 5 greater than 10? No, it is not. So it's not going to execute what's in the if statement. Instead, it's going to go on to what the else statement is. So if-else statements present us with two options. They say basically, they give us a check. If something, do that. If one condition is true, do this. Otherwise, do this. Now, it's important to know that the else statement is completely optional. So I'll comment this out for right now so that I don't completely erase it. The else statement is completely optional. Print done. So let's go ahead and just add the other part because I said please enter a string. I'll tell you how long it is, so let's not be liars about it. Let's print the size. And then we will say, if the string is greater than 10, we'll print out that's a big string. And then we'll print out done. And the done's going to happen regardless of whether or not it's a big string. So I'm going to put in hello world, which is 5, 6, so more than 10. It's 13 characters long. That's a big, so if size is greater than 10. 13 is greater than 10, so we enter the if statement. We print out that's a big string, and we're done with it. And then we're done with that block, and so then we get out of the if statement, and now we print out done. So how do we know that that we're inside an if statement? What makes it be inside an if statement? Inside the if. Indentation. So other languages use curly braces, and then they say you should indent stuff to make it easy to read, and Python was like, well, actually, if we're going to indent stuff and make it easy to read, then we don't actually need curly braces at all. We don't need weird symbols thrown around and have to match up. Things are part of another state, are part of a block of code, of the same block of code, if they're in the same indentation. So here, yes?
I was going to ask, why does else use
the comments?
Oh,
I'm making that.
No, not that one. At the end of else.
The semicolon?
Yeah.
It's the same thing. It's the same thing over here. You've got a colon over here. So the colon is how we use the colon to denote that this is the end of a if statement. Well, it lets us know that this is that we're beginning our statement, that we're beginning this is the end of the conditional. I mean, I think it's more for the, I don't know if it's mainly for us or for the interpreter, but I think it's more for the interpreter, and that makes its job easier to know whether the statement has ended. So if the size is greater than 10, print out that's a big string inside the if. So we'll go ahead and run that, and then I'm going to run it. So I'm going to run it once with hello world, and then so that's 13. That's a big string inside the if. Now we're outside, right? So that's a big string inside the if, outside, done. Now if I run this again, but this time I just put foo, prints the size 3. If size is greater than 10, well, 3 is not greater than 10, so we skip the entire block. We skip the entire if-else state. We skip the entire if statement. We print outside, and then we print done. So I'm going to delete the bit of outside because now we're going to add the else back in. And the else is, again, completely optional. It executes, if you have an else, it's basically, you have two mutually exclusive events. Basically, you're saying that we either do this or we either do that. Okay? So let's go ahead and see if the size greater than. So let's go ahead and enter a string. We'll enter a bunch of numbers. That's a big string inside the if, done. Now if I enter a small string, like, oh, that's 3 long, foo, it'll print out that's a small string. All right, so you can have as many if statements together. The question is whether or not they are mutually exclusive of one another or not. Okay, so you can either have independent ifs or they can be interdependent, and you're about to see what I mean by that. And it all depends on how you structure it and whether or not we use something called an elif. But we'll get into that. So now let's see if we want to check if the user enters a really big string. Let's say if the size of the string is 15, that's a really big string. And remember, the way Python works is that it doesn't really look at the whole program all at once. It looks at small chunks of it. So it doesn't necessarily, so it executes stuff quite literally. All right, so if the size is greater than 15, print out that's a really big string. Okay? So now if I do, let's say, foo, bar, baz, Fred, Frob, Izzy, that's 26 long. And so it says, so it prints out 26 because that's the size of the string. And then it goes, is the size greater than 15? Well, 26 is greater than 15, so I'm going to print out that's a really big string. Then it goes on, so we're done with it. So we continue on to the next one, and it says, is the size greater than 10? Well, size is greater than 10. So we're going to print out it's a big string inside the if, and we didn't do the else. Why don't we do the else? Well, because each if gets only one else statement possibly attached to it. Else is only attached to the if statement immediately preceding it. Okay? But it's kind of contradictory, right? If we want something to be bigger than 15, we don't necessarily want it to be also printing out, you know, we don't want it to print out the middle option necessarily. So we can combine, and one way to do this is that we could do something weird. We can combine ifs and elses together. So we could say, well, if it's greater than 15, we do this. Otherwise, if the size is greater than 10, and notice now how the if statement over here is inside this else block. How do we know it's inside this else block? Because it's indented. So you can nest these things as deep as you want it to go. However, you can see basically if we wanted to, if we want to do something like this, if, so let's say if size is greater than 7, print that's kind of a big string, right? You can see basically that as we do this, as we get more and more options and make the program more and more complex, the indentation becomes even more and more nested, and if we add more and more options, it gets nastier and nastier. And that's not something we want to do, I don't think. So instead, what I'm going to do is I will go ahead and just leave this as an example of what not to do, right? So I'm going to comment this out. I'm going to keep it here so that you guys can have it for later to refer to. But instead, we've got a better structure for that. We have something called the elif, right? So let's go ahead and grab this first if statement again. So if the size is greater than 15, we'll print out that's a really big string. And elif can be like, you can consider it as an else and an if combined, right? It's kind of this thing, and they're all a bunch of choices just stacked together. And elifs basically say so an elif, if else if block says it's got to be one of these choices. And if it's not one of these choices, if we have an else at the end, it's this one by default. Size is greater than 7, sorry, greater than 10, print that's a big string. You can kind of think of it as a, like this as a if this, but if it's this instead, and then if we have another one, but if it's this instead. So else, so elif. And in other programming languages, it's sometimes else if, like that. In Python, they just, again, combined it into an elif statement. Greater than 7, print. Now, you could possibly do this with just if statements and like using like greater thans and less than statements, but then we'd have to introduce ands and stuff, and I don't want to do that quite yet. That's a kind of big string. Else. Print. And the logic, so the logic all follows the same thing as what I have commented out. But it's much nicer looking here. And the idea here now is that if it's greater than 15, do this. But if it's not greater than 15, but it happens to be greater than 10, do this. But if it's not greater than this one, but if it's not greater than, but if it's not greater than 10, but it happens to be greater than 7, do this option. Otherwise, do this one. Now, as you might be thinking to yourself, it's kind of important that these things happen in the order that the order that you put these in really matters, right? Because if we have the 7 here first, well, 7 is smaller than 10 and it's smaller than 15. And if we check, right? So if this condition came first, then it would execute the kind of a big string no matter how big it was. So let me go ahead and just show you that this works, and then I'll show you that hello. So this is 11, so it's going to print out that's a big string, right? It wasn't a really big string, it was a big string. And then if I run this again and do hi, well, 2 is not greater than 15, 2 is not greater than 10, 2 is not greater than 7, else, well, I guess it's a small string then, so we print out done. Okay. Now, this is useful because sometimes you want to execute code based on certain conditions. And we can basically set up whatever kind of conditions we want. But having your logic correct is important. For example, if I accidentally decided to rearrange stuff, like, so 7, and then if I swapped it around like this, then you'll notice that what happens if I put in hello world, how are you? It says it's 26, but it's kind of a big string. Now, why is that? Well, if 26 is greater than 7, oh, that's true. Okay, that must be the condition you want, so I'm not going to bother checking any of the others, right? We choose only if you've got, so this block is all one thing, and it chooses just one option. Okay. Now, if they were just, if they were ifs, right? If they were if statements, that means they're independent of each other. And that's a subtlety that you'll learn, that you just have to learn through, unfortunately, making mistakes. Right? 15, that's kind of a big string. That's a big string. 15 isn't bigger than 15, so we don't do that. So since it's not bigger than 15, it's a small string, right? That's why it prints out all those 3. So let me go ahead and undo all this thing and just save this program as a working program. All right? Not too bad there. Okay, so this statement over here, this was an example of a Boolean statement. Let's see, do I still have size over here? Yes, I have size. So size greater than 10. That turns back, that gives me a Boolean statement, true. Okay, so Boolean statements, true and false statements. They're pretty awesome. They're named after this fellow over here. A self-taught English mathematician called George Boole. He wrote a book called The Laws of Thought, which honestly sounds pretty pretentious, but I mean it was pretty important. Which contains Boolean algebra, which is all these kind of algebra that you can do with true and false values, right? Things that are true and not true, and we use zeros and ones. And if you remember from last lecture, I mentioned that computers just deal with zeros and ones, right? So this kind of stuff became the building blocks for what circuitry could do. Because it turns out you can do stuff like define addition of 2 numbers just by like hooking together a bunch of circuitry that does these AND operations and OR operations and NOT operations. And that's, and yeah, they had more formal names for conjunction, disjunction, and negation, but honestly, and or not sounds a lot shorter. It's easier to write. So we use and or and not for Boolean values. So let's go. So I'm going to take this compiler and run it through the here we go. Let's do this. So let's go ahead and say like some basic stuff. So Boolean values can be either true or false, right? So you can store them in a variable. B is equal to true. Can everybody see at the bottom? I don't. Okay. So B is equal to true, right? Print B, true. Now the not operation which is literally the word not, does the opposite. It takes a Boolean value and throws the opposite at it. So not true is false. So you can stack these up, by the way, not B, right? So, and it just works from, so true, not B is false, and so not false would be true. Okay, so sorry, not B, so it gives me true again. Not B gives me false, and there's never no reason to do this. So so there's really don't do this if you can avoid stacking these things up. So there's a now let's go ahead and I'm just going to see this should really only work for you'd think this would only work on let's see. You'd think it would only work on Boolean values, but it turns out Python's a bit quirky. Not 5 gave me false. Okay, not 0 gives me true. So this goes back to what I was saying earlier about values having a truthiness, right? They aren't true or false, but they're kind of true or false. So if you have a value and it's not a 0 value, so then it's true. If it's a 0 value, it's false. So for instance, if I were to say something in my code, let's go ahead and make a script just so I can save, so you guys have something to reference. So new, I'll call it, really it needs to start saving in teaching in classroom. Okay. Now, I think this is called truthiness, but that's what I read on the internet, and as Abe Lincoln has said, don't believe everything you read on the internet. So, so I may just be repeating a pile of bullpucky, but values do have a truthiness. So let's go ahead and print. So for instance, if, let's say x is equal to 5, okay? If x, I'll go ahead and start out with I'll start out with b is equal to true. Let's start out with something easier. Remember, all these things are expressions, and expressions get evaluated. So if b if b, let's go with that felt true. Else I'm trusting my gut, and it says this is false. Okay, pretty basic stuff there. Let's go ahead and get back into this format. So, and it says, let's just get this on one so we can read it on one line, and it says false. Okay, so if I run this and it says if b, that doesn't seem like much, but right, but b is a Boolean value, right? So b will be evaluated to right. B is something. It's going to evaluate to true. So that felt true, right? And if I put x there, well, that's a non-zero value. That felt true as well. I put 0 over here, though, the x is going to evaluate to 0, right? And we're going to consider zeros to be false. Now, I don't consider it good practice to do this. If you want to be clear about it, we've got other ways to do that, right? And I'll get into that in just a second, right? We were dealing with comparisons, right, in the beginning, like 5. So if x, so right, we were dealing with like if size is greater than 15. So let's say size is equal to 15. So if size is greater than 12, that's true. Size less than 12, that's false, right? So these kind of operations, greater than, less than, they're Boolean operations, right? They're the kind of logical operations we can do. Let's see. I believe, yep, Boolean expressions, logical operators. So there's the logical operators, and then there's these, okay, the formal name for them are relational operators. Okay. So size is, because they set up relationships between things. Size is less than 12, or they establish relationships. So you've got greater than, let's say size is equal to 12, okay? Is size less than 12 now? No, it's not. 12 is not less than 12. But as I mentioned earlier, there's also less than or equal to. Is size less than or equal to 12, right? So there's 6 operators. Let me just go ahead and switch onto the board for a second. So you've got a couple of operators here. We've got greater than to check if x is greater than y. We've got also less than to check if they're less than. We can do greater than or equal to check if one thing is greater than or equal to another thing. Less than or equal to, right? Let's see. Yep, let me see. Yep, we've got not equal. Yeah, and then we've got equal and not equal. Okay, I just wanted to make sure that I thought I saw something weird there, but I did not. And then if you've got less than or greater than, and you've got greater than or equal to, you've also got the ability to check if 2 things are the same, right? And it's this, 2 equal signs. So this is checking if 2 things are equal to each other, okay? 2 equal signs means checking if 2 equal things are equal to one another. 1 equal signs means we're doing an assignment. 1 equal sign means that we're taking taking the right and putting it on the left. And yes.
I was going to ask, is that recording supposed to be able to see?
It does on my screen, so don't worry about that. It's okay. It's the projector being dumb. Okay, the projector being dumb, and I'm gonna actually call IT after this class and say, hey, can you help me fix this? Okay, so, and then to check if 2 things are not the same, we can do a exclamation point equal or not equal. Okay, so let's go ahead and get back to the regular camera. All right, so, and we can just, so like 13 is equal to 12, right? That's false, obviously. 13 is equal to 13, that'll return true. True is equal to not false. So we establish each side, right? So true, not false gives us, evaluates to true. Invalid syntax. Ooh. Unexpected indent. Not true. Gives me false. So this tells me something about the way that I can arrange operations. So yeah, looks like that will have to go at the beginning of something. But what about this? True. Can I do this? Also invalid syntax. So keep that in mind with the not operator. So let's go ahead and see what we can do. But true, not equal to false. True.
Could you do the inverse of those two? So like not true equals.
Not true equals false, because there you go. Not true equals false. So true and false compare to each other, right? That returns true. sorry, that returns false, and the not will flip that to true.
What about the bang false?
I don't think that's. I don't think bang is allowed. Yes. Parentheses. Ah, there we go. True. Equals not false.
Like not false is in all parentheses.
Ah.
That's a straight,
So putting it in parentheses allows it to evaluate like that. Good catch. So we've got those operations down, and then there's two more to do called and or. All right. So and or are kind of let's go ahead and go with okay. So let's go ahead and set up some conditions that we can see in combination with one another. So and says if both of these conditions are true, then the whole thing is true, right? Let's go ahead and see. Let's go with feeling dead is equal to, let's say that's a true or false value, right? Let's go with true. Hungry for brains equals true. Okay, so if you're feeling dead, like you're dead, and you're hungry for brains, then obviously you're a zombie. Those are like the two classical conditions for being a zombie, yes? Right? If for anybody who's watched a horror movie, right, those are the two classical conditions for a zombie. So if both of those things are true, both of those conditions have to be true for you to be a zombie. So if we were to write an if statement to check if somebody was a zombie, feeling dead, and hungry for brains, and it's that simple, just having the keyword and. Now, other programming languages do use the ampersands instead, but Python was like, why bother? Just use the word and. Actually, Fortran used the word and a while back. They just happened to do it in like this with dots there, and Python's like, no, this is much easier to read. We'll do it like this. So if you're feeling dead and you're hungry for brains, print you're a zombie, but we don't use the Z word. You notice that in all the movies they never use the Z word, right? So yep, you're a zombie, but we don't use the Z word. But if I'm not hungry for brains, right? If this is false, right? Then it doesn't execute there, right? Both the things have to be true in order for the whole thing to be true, right? To be a zombie, you have to be feeling dead and you have to be hungry for brains, right? So if you are like maybe you're hungry for brains, and let's go ahead and say, let's go with, we'll keep it in the same order. So feeling dead equals false, right? So if feeling dead is false, and hungry for brains, and for the sake of readability, I'm going to say if hungry for brains is true, right? So if feeling dead is false and being hungry for brains is true, and we can throw parentheses around these suckers so that we can just
You're cannibal.
Yep. Print oh, we're in a cannibal movie, right? Print Don't eat me. I'm a clown. I'll taste funny. Yes, I'm that guy. So, let's go ahead and say, let's say, what if you're, so, let's go ahead, so basically, right, for one, so this has to evaluate to true, and this has to evaluate to true, right? So let's go ahead and switch these up to make sure that the proper one executes. So if feeling dead is false and hungry for brains is true, we run this, and it says, okay, feeling dead is equal to false. So this single statement over here, this evaluates to true, right? Oh, can I? Yeah, so let's go ahead and, there we go. So this single sentence evaluates to, so this single statement evaluates to true, right? This, well, substatement, this expression evaluates to true. And if we're hungry for brains, if hungry for brains is true, and that evaluates to true, so if this was true and this were true, we're in a cannibal movie. What about the opposite? What if feeling dead equals true and hungry for brains equals false? Ghost movie. That sounds good. I was gonna go with oh no, we're in some edgy drama about work, but print.
Or Twilight.
Ghost movie. I like this one. Ghost movie. They're never really that scary. Ghost movies never really live up to any hype.
They played off the shock thing.
It is a disappointment that basically shock value is kind of an issue. My favorite, the best horror movie I saw in a while was Cabin in the Woods, and that was from a while ago. That was great because
Horror movie.
it's a deconstruction of it, you know, and it rebuilds kind of the expectation, and it's kind of these shock horror movie stuff is no good, so this is fun. Have fun with a horror movie. Mind you, I can't watch too many horror movies these days because I've got a wife and kid at home who do not really appreciate horror movies. So, all right. So that's pretty good for this example, I feel. All right. So that's the if statement. The or statement is a bit different. So, and then I'll let you guys. Then I'm going to get you guys to do some work. Okay. The or statement is slightly different. So let's say if x is greater, so let's say x is equal to 10. If x is greater than, let's say if x is greater than 5, right, that's obviously going to be a statement. If x is greater than 5, print foo. Right? Nothing too complicated there. Let's go ahead and throw it into a script because I'll need something that I can constantly rerun. Yes?
Can you use like and or together?
Yes, you can. So the question, of course, is which one takes precedence, right? Which one executes first? But for right now, we're just going to look at the ands and ors separately from one another and knowing which one to use. So let's go ahead and say if let's go with doing something again realistic. So teaching. So let's go to classroom and rainy or.py. So this is the classic example. If so, if, so let's go with raining is equal to false, and bad forecast is equal to true. Okay, if raining or bad forecast, print pack, bring an umbrella. Else, I'll probably be fine. Right? So this is if if either of these are true, then the whole thing is true. Right? So today it wasn't raining, but we've kind of got a bad forecast for today. So obviously you want to bring an umbrella. Okay? If it's raining and there is a bad forecast, then yeah, totally bring an umbrella too, right? It's because it's raining and there happens to be a bad forecast. So with an or statement, it's only false if both are false, right? With a true, with an and statement, they're true. Sorry, the and statement's only true if both parts of the and statement are true, right? With a or statement, it's only false if both parts are false. Right? So if it's raining, but there's not a bad now, but there's not a bad forecast for later, right? I should still bring an umbrella because it's wet outside now. Right? If it's going to rain later because there's a bad forecast and it's raining now, then I definitely want to bring an umbrella. And if it's not raining now, but there's a bad forecast, but it's going to rain later, definitely bring an umbrella. But if it's not, I'll probably be fine. All right. So let's go ahead and take a look at your assignments that I've got put up for you. So some of them, what's very interesting is that if you've programmed before, we're about to hit one of the assignments that doesn't really care about the amount of programming experience you have. But for right now, we're going to. So in other words, if you feel like it's hard, and you've programmed before, don't lose hope because it's meant to be. So you can work on either Messy Chocolate if you haven't finished it yet. Right, the one that we set up earlier with the whole, and you don't need to use if-else statements at all for that problem, right? Right, that one was just simply testing you. 3 small problems. This one is hopefully what we'll work through in class, but these are like 3 small programs that I feel like are worthwhile to work in class. And you can put them in functions or in different files if you want, or you can put them in all the same file. It doesn't matter to me. It's got 3 very basic problems that are kind of classical beginning problems. The first one is 3 sort, where you ask the user to enter 3 numbers, just 3. You can do that however you want, and then it prints them in sorted order, right? So this is just obviously if statements and else statements, right? So if you've got 3 numbers, and you just got to figure out, okay, how do I put them in order? And you use if-else statements to do that. Temperature. This one's another classical one where given a temperature, it will convert it from Celsius to Fahrenheit. You can do Celsius to Fahrenheit, or you can do Fahrenheit to Celsius, right? Both are both perfectly good tools for you. You only have to do one direction though, right? You should prompt the user for the input. Tell them whether they're expecting Celsius or Fahrenheit. Then you're going to read basically a floating point value from the keyboard, right? So something that's like, like maybe you'll say 32 degrees, right? And then you'll calculate the result. And here's the formula. And this is the same as I gave the same assignment I'm doing the same assignment in Java, so this doesn't really matter so much for you guys. But remember, since you're dealing with floating point numbers, you want to use regular division as opposed to integer division. And the final small problem is seconds to hours. So again, this comes from the textbook. These second 2 come from the textbook. Write a program that takes in a number of seconds and converts it to hours, minutes, and seconds. So this one's going to be possibly the trickiest one of these three, because what you need to use the modulus operator. So in other words, use that modulo operator, that remainder operator to figure this out. But it converts seconds into hours, minutes, and seconds. So again, get input from the user, read input from the keyboard, and calculate the result. Okay. So go ahead and get started on that. I'm going to end this recording. I'm going to change an answer on a quiz change a question on a quiz because it needs to be updated to reflect the fact that we're in Python. And then I'm going to go and make around the class to make sure that everybody's working on something and making progress on something. Again, if you feel like the assignments are just hitting you way too fast, right? I'm gonna just let me know, and so we can speed it, so we can slow it down, because you're probably not the only one who feels so.